Okay, this is the P4 paper from June 2023. It's question number 7. This one is a proof by contradiction question, as we can see up here. And actually, it's a very standard one. This is actually in the Edexcel book, so you can go and have a look for root 2 it does, but it's following the same process I'm going to go through. For any proof by contradiction, what we will do is we will assume, and generally, the opposite of what I'm trying to prove. So I'll assume something. When I assume the opposite, obviously I know that that doesn't work, I then go through a mathematical process, and at some stage I will get to some sort of impossibility. When I get to that, I say, oh, my assumption is wrong. And if my assumption is wrong, then the opposite, in this case root 7 being irrational, has to be true. Okay, it's a bit complicated to explain it like that, so let's actually go through and do this one. But please make sure you put all your working out down. Don't just do the math side of it. You've got to get the layout right here as well. So if I'm trying to prove that root 7 is irrational, my false assumption is going to be, I'm going to assume the opposite. So in this case, I'm going to assume that root 7 is rational. Okay, so I'm going to assume that root 7 is rational here. If that's true, then root 7, rational means it's able to be written down as a fraction. So root 7 can be written down as a over b. And I know what I'm going to do with this simply because I've done this, or looked in the book and seen the example there. It's a over b, where a over b is a fraction. That's not the key. The key is that it's a fraction in its simplest form. And that's where I'll have a contradiction later on, just because I've done this one before. So you'll see what that happens when we go through and just do the proof. Okay, so if root 7 equals a over b, I want to get rid of that square root, so I'm going to square both sides. As I said, I'm going to go through a mathematical process. This time, it's squaring both sides to start off with, which gives me 7 is equal to a squared, over b squared. And then we can take the b squared up and we can say 7b squared is equal to a squared. So at this point here we can say if a squared is equal to 7b squared, then what this shows me is that a squared is a multiple of 7. So we're halfway through the proof already now. And if a squared, is a multiple of 7, then a is a multiple of 7. So if a is a multiple of 7, I can now say a is equal to 7k or 7n, 7 some other value there. If that's true, then a squared equals 49k squared. So I'm just going through, following mathematical processes. Everything should follow through, obviously, automatically. So if a squared is equal to 49 squared and a squared is equal to 7b squared, then I can say, okay, so 7b squared is equal to 49k squared, which means that b squared is equal to 7k squared, which then means that b squared is a multiple of 7. And if b squared is a multiple of 7, then b is a multiple of 7. And what we've now got is our contradiction here. If a and b are both multiples of 7, then a and b is not in its simplest form. So I need to write that down then. So if a and b are both multiples of 7, then a over b is not in its simplest form. So if that's the case, therefore, my assumption is wrong. The bit that I assumed first of all doesn't work, is false. And if my assumption is false, then the thing I was trying to prove has to be the opposite. So therefore, root 7 is irrational. Okay, just quickly then to go back over that. Easier to explain now that we've done the question. So if I'm doing proof by contradiction, I'm assuming the opposite of that. So I'm assuming something that I know, hopefully, will not work at some stage. We then go through a process. The processes can change each time, but I go through a mathematical process, and at some stage, I end up with a contradiction. In this case, I'm getting that my maths doesn't work for whatever reason. So in this case, I'm getting that the fraction is not in its simplest form. So if that's the situation, then my assumption is false. So the thing I was trying to prove was true. So always a false assumption, go through the work, then say that it doesn't work, your assumption doesn't work, and so that means that what we were trying to prove in the first place does. A little bit complicated, but if you've done the one in the book and now you've seen this one, hopefully you're building up a bank of those that make sense.